Hi everyone, and welcome to the AI Research Roundup. I'm your host, Alex. Today, we're diving into this article by Google Research titled, Evaluating Progress of LLMs on Scientific Problem Solving, published April 3, 2025. Well, the core idea here is that current benchmarks for large language models, they just aren't cutting it for real-world scientific problems. So this post introduces three new benchmarks, CURIE, SPIQA, and FEABench, to really push LLMs on long-form scientific text, multimodal data like figures and tables, and complex reasoning. So this figure dives into the input and output lengths for the CURIE benchmark. The left side shows the input length, the queries given to the model, varies across the different scientific disciplines. Okay, it looks like the average is around 15,000 words. Then, on the right, we see the length of the correct answers. The ground truth averages about 954 words. So pretty substantial outputs as well. Okay, so this table breaks down the 10 tasks within the CURIE benchmark. It lists the number of questions for each task, a brief description, and the capabilities being tested. We also see the output format: JSON, text, LaTeX, YAML, and even code. Finally, it shows the primary evaluation metric used, like RUGEL, LLM, SimF1, or intersection over union. So it really gives a good overview of the diversity of challenges presented within this new benchmark. Alright, moving on to the results. This figure shows the performance of various large language models on the different CURIE tasks. We see scores for, a range of LLMs, Gemini, Claude, GPT-4, and others across those 10 tasks like DFTS, DFTP, all the way to PDB, which we saw in the table. And it's pretty clear that even the best models, they're still scoring below, often significantly below 0.6. So there's definitely a lot of room for improvement. So this figure visualizes the performance, the average normalized performance actually, of several large language models on the CURIE benchmark. We see Gemini 2.0 Flash performing the best, followed by Claude 3 and, a few other Gemini versions. Interestingly, even the top performer is only scoring around 0.32, really highlighting the difficulty of these scientific tasks and, how much improvement is still needed. Okay, so this table provides some statistics about the SPIQA benchmark. It's based on roughly 26,000 computer science papers published between 2018 and 2023, from which they extracted over 117,000 tables and, get this, over 152,000 figures. These figures are further categorized as schematics, plots and charts, visualizations, and other. And, importantly, almost 270,000 question-answer pairs were generated from this data, with average question and answer lengths being relatively short. Next, this table shows some key stats about the SPIQA benchmark. It's built from roughly 26,000 computer science papers, and it includes a breakdown of the various subdomains like AI/ML, NLP, and vision. The pie chart, that shows the distribution across these areas, with AI/ML making up almost half the dataset. The table also highlights the sheer scale, over 117,000 tables and 152,000 figures, categorized as schematics, plots, visualizations, and others. Wrapping up this article by Google Research, they've introduced these three new benchmarks, CURIE, SPIQA, and FEABench. They really push LLMs to handle complex scientific tasks, long scientific texts, figures, tables, and multi-step reasoning. The key takeaway here is, current LLMs show promise, but still need significant improvement to truly assist scientists effectively. Okay, thanks for tuning in to the AI Research Roundup.